Hey everybody, today we have an exponential inequality that we're going to try to resolve. I want to write down a fundamental result that we're going to be using to solve this. It's called the AMGM inequality, and I'm just going to use a simple example. 7 plus 3 over 2 is the arithmetic mean of 7 and 3. That's always going to be greater than the square root of the product of those two values. So I'll put 7 times 3 here. Okay. And it's strict. If they're equal, then there would be an equal in here, you know. But anyway, this is the arithmetic mean. This is sometimes called the GM inequality. Nobody wants to take the time to write down the arithmetic mean, which is with respect to addition, geometric mean, which is with respect to multiplication. Now, you know, something I like putting here, even though it's left out by a lot of people who teach this stuff, is this divisor actually becomes the index of a radical right here. Okay, and so it relates, it's a fundamental inequality that relates addition and multiplication. So believe it or not, we're going to use an expanded form of this to solve this problem. We want to prove that you've got an exponential situation, not exponential, I guess you can think of it if you want to write this as 14 to the 1/13th. But we can rewrite what we're trying to prove equivalently just like this. Okay, just like this right here. All right, and you can see what I did. I brought the 13 over to this side and then divided by 13. Okay, that's exactly what happened. Just rewrote it in a form that makes it amenable to the AMGM inequality. And so right here, we're just going to work with the left-hand side. So I'm taking this left-hand side and placing it right here. Now, the first big step that's a simple but sometimes forgotten idea is you can just write 13 is the sum of 13 ones. 1 plus 1 plus 1 plus ellipsis plus 1, right? And of course that's 13 times, I won't write that down, 13 times 1, 2, 3, all the way. You see them all there? 13 of them, right? And so that's what I did right here, 13, 1 plus 1 plus 1 plus 1 plus 1 plus 1 right here, right? Now you go, what's the benefit of that? Well, on the very next line you'll see 1 plus 1/2 is 3/2. 1 plus 1/3 is 4/3. 1 plus 1/4 is 5/4, all the way out to 1 plus 1/13 is 14/13. And now we can apply the AMGM again. The AMGM, you see how we have a 13 here and a 13 here? Divisor, index, all right? And notice a very nice thing happens. This 2 cancels with this 2, this 3, I guess telescoping fractions, 3 cancel with this 3, 4 cancel with this 4, all the way out to 13 canceling with 13. All right, now this is equal to, you guessed it, the 13th root of, or that one was left from last time, I guess. The 13th root of 14, right? Yeah, that's supposed to be a 13 index, all right? 13th root of 14. Can't tolerate that. Let's make it like that. Okay, the 13th root of 14, so we are done. Quandam est demonstrandum, thus we have demonstrated, we have finished the proof. Quite easily done, sort of. All right. So that's it, folks. Thank you for viewing, and we proved what we set out to prove.